What is the primary purpose of using kernel approximation techniques in machine learning using scikit-learn? A. To improve the accuracy of linear models by introducing nonlinearity. B. To reduce the computational cost of kernel-based algorithms, especially with large datasets. C. To handle high-dimensional data by projecting it into a lower-dimensional space. D. All of the above. Correct kernel approximation techniques like random Fourier features allow linear models to learn nonlinear relationships in the data, effectively extending their capabilities beyond linear decision boundaries. A. To improve the accuracy of linear models by introducing nonlinearity. Correct kernel approximation methods aim to reduce the computational complexity associated with kernel calculations, particularly when dealing with large datasets, by approximating the kernel function with simpler functions. B. To reduce the computational cost of kernel-based algorithms, especially with large datasets. Correct kernel approximation can help handle high-dimensional data. Techniques like Nystrom approximation and random Fourier features can reduce the dimensionality of the data by projecting it into a lower dimensional feature space, making computations more efficient. C. To handle high-dimensional data by projecting it into a lower dimensional space. Correct all the options A, B, and C accurately represent the benefits of using kernel approximation techniques in machine learning. D. All of the above. D. All of the above. Kernel functions are essential in machine learning, particularly in kernel methods. They quantify the similarity between data points in a high-dimensional feature space. This similarity is used to make predictions and classify data. Image recognition kernels can be used to compare image patches, helping identify objects within an image. Natural language processing kernels can help measure the similarity between sentences or documents, facilitating tasks like text classification and sentiment analysis. Recommender systems kernels can be used to find similar users or items based on their preferences or interactions. Let's consider the linear kernel kx1, x2 by 1 tx2, given two data points x11, 2 and x23, 4. The linear kernel calculates their similarity as kx1, x2, 1, 3, 2, 4, 1, 1. Kernel approximation techniques are essential when dealing with large datasets or high-dimensional data where direct kernel computations become computationally expensive. They aim to approximate the kernel function with a simpler function, reducing the computational burden without sacrificing much accuracy. Image classification with deep learning kernel approximation techniques can speed up training deep convolutional neural networks by approximating the dot product operation used in the neural network layers. Large-scale natural language processing kernel approximation can handle large amounts of text data, enabling efficient text classification and sentiment analysis in applications like social media, monitoring and customer reviews. Personalized recommendation systems kernel approximation can scale personalized recommender systems to handle vast user data and item information, allowing for efficient recommendation generation. Nystrom approximation given a kernel matrix K. The Nystrom method approximates it using a subset of data points called landmarks. It calculates the kernel values between the landmarks and all other data points, effectively reducing the size of the kernel matrix. This can be used in various applications, like dimensionality reduction and kernel-based machine learning algorithms.